Hello and welcome to Empowered Learning. This is video number 3 in the Radical Expressions video series. The next set of examples that we'll do here is converting a rational expression into fractional exponent form, as well as taking something in fractional exponent form and putting it back into nth root form or radical notation. After that, we will look at some expressions that either contain fractional exponents and or radicals and try to reduce those to lowest terms as well. Okay, and with that, we'll go ahead and get started here. So we first want to write each radical expression using our exponential notation. And so just to remember, we know that if we have something written in the nth root form like this, then we can rewrite it in the fractional exponent form as x raised to the m divided by n. And so we're going to be using that to rewrite these particular expressions in exponential form. All right, so for A, we see that we have the expression CBS all under the cube root sign, and we know that CBS all together, if we just view that as a simple expression, that would be all that raised to the power of 1. And so because of that, we can rewrite cube root of CBS as CBS raised to the 1 divided by 3 power. Okay? For example B, we have 5y under a square root sign, so we can rewrite this as 5y, all of that raised to the 1/2 power. For example C, we know that we have the 4th root of 7, and so one of the things that we need to make sure that we understand is that 7 is the same thing as 7 raised to the power of 1. So using our rule on changing a radical expression to a fractional exponent, we see that of course the 1 would be m and the n would be 4. So x raised to the m divided by n. Of course, if our x is 7, would just be 7 raised to the 1/4. And so that's how we get that. Okay, so go ahead and erase this, and we will carry on. So for example D here, this would be a raised to the 5/3 power. For E, notice that we would need to take our expression that's in the denominator and rewrite that in fractional exponent form, 2 raised to the 10/3. And then we use our reciprocal exponential rule here to basically say that 1/2 raised to the 10/3 is the same as 2 raised to the negative 10/3. Okay, and so same kind of thing here. There's a couple different ways we could go about doing this one. The way that I'm going to go is I'm going to simply change 1/a raised to the 2nd power as a raised to the -2 power. And then from there, if we do the conversion, that will be a raised to the -2/3 power. All right, so let's go ahead and move on. And so now we're going to go the other way. We're going to take our fractional exponent and fractional exponent expression rather, and we're going to change that back into a expression in radical notation. Okay, so for example A, we know that anything raised to the power of 1/2 is just the same as square root of whatever the base is. So in this case, when we do this, we have a -c raised to the 1/6, so that would be the 6th root of -c here. And of course, we would assume here that c is going to be some value that is going to be less than 0, because we know that for the even nth roots, we can't have any any negative numbers under the radical there. Okay. All right, so for the next example here, we know that this would just be the fifth root of 9. For example, D here, this would be the same as 1 over W raised to the 3/4 power, which would be the same as 1 over the fourth root of W cubed. Okay? And so same deal here. We know that 3m raised to the -1/5 power is the same as 1 over 3m, all that raised to the +1/5 power. And then that would just be the fifth root of 3m. Of course, the last example, F, 6 raised to the -5/3 is the same as 1 over 6 raised to the +5/3. And we change 6 raised to the +5/3 to the cube root of 6 raised to the 5th power. Okay. And of course, if we wanted to, we could go ahead and figure out what 6 raised to the 5th power is, and that would be 7,776. So if you wanted to go one step further here, not necessary, but if you did, then you could just do that. Okay. All right. So now that we have that done, we'll go ahead and simplify the expressions in the next set of examples here. So first thing that we see here is if we wanted to do this, one way that we could go about doing this is we could just say this is going to be the square root of 16 cubed, okay, which is the same as square root of 16 times 16 times 16. And of course, if we break those up separately, we know each one of these will equal 4. And so 4 times 4 times 4 would just be 64. So that's what the answer to that one would be. For our next example here, we would just say this is 1 over square root of 25 raised to the 3rd power. And so this would be the same as square root of 25 times itself 3 times. So square root of 25 times square root of 25 times square root of 25. And of course, square root of 25 is just 5. So that's the same as saying 1 over 5 times 5 times 5, which is 1 over 125. Okay. Our next example here, notice that we have a -8 raised to the -4/3 power. So we do the reciprocal rule first. Then after that, we translate our denominator into radical form. And notice that -8 raised to the 4 is the same as -8 raised to the 3 times -8. And so we see that we have 3 factors of -8 that are under the cube root sign so that we can pull one out. And we notice that what's left here is 1 factor of -8 under the cube root sign, but we know that -8 is the same as a -2 times -2 times -2, or -2 raised to the 3rd power. Okay, and so I'll go ahead and write that up there just in case you need a visual. So here, I'll just put it here. So we know that cube root of -8 is just the same thing as cube root of -2 raised to the 3rd power. And so we have 3 -2's under there, so we can pull one out. And so from that, 1 over -8 times -2 is 1 over 16. Okay. Same deal here. We have a -100 square root of, I think I started that off wrong here. So let me go back. All right, so here we want to start off by doing 1 over -100, all that raised to the +3/2 power. and then from there doing square root of negative 100, all that raised to the third power. And so from there, if we keep going, we'll see that we have, we're pretty much going to have an issue here, because we know that if we take negative 100 and we cube that, that's going to be a negative 1 million. That's with 6 zeros. And of course, our problem here is that we cannot take the square root of a negative number. So this case would end up being no solution. We would not be able to evaluate that. Okay. For the next example here, we have 3 raised to the 1/3 times 3 raised to the 1/4. And so what we're electing to do here is, we know that we have the same base in both of these exponential expressions. So we are converting, or taking these fractional exponents and writing them as equivalent fractions so that we can add them together here. And of course, we have 3 raised to the 7/12. And of course, we can put that back in radical form. Okay. If we do the same thing here, we see that the bases are the same, denominator of the fractions are the same. So we could actually add the exponents here. And we know that 1/4 minus itself is 0, and anything raised to the 0 power is 1. Okay. For the next example, we have 2 exponential expressions. The bases are the same, so that we can subtract the exponents. So that will be negative 2/3 minus a negative 1/3. And of course, minus a negative is the same thing as addition. So that would be addition there. So that would be 27 raised to the negative 1/3. And of course, that's the same as 1 over 27 raised to the positive 1/3, which is the same as cube root, 1 over cube root of 27, which will be the same as 1/3, since 3 times 3 times 3 is 27. All right, and so for last example here, we notice that the exponents are the same, but the bases are not. So in this instance, what we can do is we could rewrite this way. And the reason that we can do that is because of this particular exponential rule that I'm going to write right here. Okay, so we see that when we have two things being multiplied times each other, all that raised to a power of n, we could rewrite that as each factor raised to the power of n on its own and then multiply. So if you notice, what we were given here is this form, and what we need to do is rewrite it in this form. So that's what we've done here. So 18 times 2 is 36, and 36 raised to the 1/2 is the same as square root of 36, which is just 6. Okay, so moving on to our next set of examples here. Using what we know about our exponential rules, we know that 3 raised to the 4, all that raised to the 1/2 divided by 2 raised to the 6, all that raised to the 1/2. And so here we can multiply the exponents. So 4 times 1/2 is 2, and 6 times 1/2 is 3. And so from there we know that this is 9, and that is 8. So that's our answer there. For this next one here, we know that we can just multiply the exponents. So we just have x raised to the 4 over 4, which is x raised to the 1, which is just x. Okay. So no need to change these into radical form to work those out. For example K, we see that we have 16a raised to the 8th, b raised to the 4th, and all that raised to the 1/4 power. So according to the same rule here, and I'll go ahead and rewrite it again, we can raise every factor inside the parenthesis to the 1/4 power. So that's what we do here, here, and here. We see that the 4th root of 16 just ends up being 2, because we know that 16 is 2 raised to the 4th power. That's what we see here. We know that a raised to the 8th times 1/4. We can multiply the exponents here, and so that would be a raised to the 8/4, which is the same as a raised to the 2. And then, of course, b raised to the 4th, all that raised to the negative 1/4 power, is the same as b raised to the 4/4 power, which is just b raised to the 1, which is just b. Okay, so we have our a squared here, our b here, and we know that 4th root of 16 is just 2. Okay. For our next example, we can take 144 raised to the 1/2 times a raised to the 8 times 1/2, which is 4. We have 9 raised to the 1/2 times y raised to the 18 times 1/2, which is 9. And so from there, 144 raised to the 1/2 is just the same as square root of 144. And 9 raised to the 1/2 is the same as square root of 9. Of course, from here, we know that square root of 144 is 12. Square root of 9 is 3. And so from there, we know that 12 divided by 3 is 4. So we just have 4a raised to the 4 divided by y raised to the 9. Okay. And of course, our next example that's here, we see that we have a raised to the negative 1/2, all that raised to the negative 1/4, so we can multiply these exponents together and get a raised to the positive 2, since a negative times a negative is a positive. And the same deal with the denominator. B raised to the negative 1/4, all that raised to the negative 4. Of course, multiply the exponents, we have b raised to the positive 1. And so we just end up with a squared divided by b as our final answer there. Okay. And so that concludes this particular video on taking expressions and rewriting them into radical form or fractional exponent form, and using those things to be able to reduce an expression to lowest terms. The next video, which will be part 4, will be on adding, subtracting, and multiplying radical expressions.